Welcome to my talk. It's titled Building a Performant and Privacy-Conscious Screen Capture Library for Compose. Whew, that's a long title. That's what you gotta do to get accepted to these talks. My name is Miguel. I'm one of the founding engineers at Bitdrift. We're a small startup trying to redefine how observability is done on mobile. Our motto is like, we've made telemetry virtually free. So yeah, going back to that mouthful of a title. Yes, today we're going to talk about how to build this, but I think it's important also to know why we want to build this. And one of the reasons is because as an observability solution, we believe that having screen captures, it's kind of important. But therefore, that comes with a lot of requirements that we want to achieve with this implementation, which is we want to build something that has minimum impact on app responsiveness, also that has minimal impact on your disk and network usage, respects user privacy, is not like invading people's privacy, and last but not least, it should work both with traditional views as well as compose views. So yeah, spoilers, this is what we're going to be building. We're going to go from screen on the left to something that looks roughly like the screen on the right. Before I'll take you there, we'll take a little detour. And again, I think it's important to understand the why we're doing this. So let's talk about how many times I have to rewrite this talk. It's probably 3 times. At some point, the title was just going to be like, how to log everything in production. Seems to be quite controversial. I think to even another title that we consider was how to get away with murder. And reason being is that you might be familiar with this famous quote from many years ago, that every time you log in production, a puppy dies. And well, nobody wants to kill puppies. So yeah, let's understand first why this is the case and how many puppies we can save. But yeah, if you look at Android documentation, like you will see all over the place that they don't want you to leave those pesky console logs in production, right? Like in the publish your apps documentation, it says, at a minimum, yes, pretty small. At a minimum, you make to make sure that your login is disabled and removed before you publish your apps. Yeah, makes sense. In the app logging documentation, they even give you like program rules about how to strip out the code that will have log statements. And yeah, it makes sense. Like most of those logs will go on red, right? Like you're trying to send them to console, but who's connected, who's looking at them, like they're wasteful, they're going nowhere. Let's kill them. What about logging to remote, right? Like it's like, okay, there's some times that I want to remotely see those logs. What's the problem with that? Like why would anyone die? And it turns out it's very hard to quantify how expensive that could be, depending on the vendor and depends on like how much data you're sending. So even for backend engineers, a lot of the time they just like log everything. Why not? It was like, turns out it's quite expensive. We have that line says that just by removing one line of a single system, we save like $300,000 a year. And yes, PY sitting here, thanks for that quote. On mobile, it's even worse, right? Like now you're like filling your network usage. You're like just using the resources of the device, and after that, you still have to pay the price. So yeah, still dead puppies everywhere. This is something that we've deemed that industrial logging complex. Like we see 2 problems with this like industrial logging complex, which is they were built for server observability. So there you don't have the problem. You need to add a log, you add it, deploy. You need to remove a log, remove it, deploy again, done. You solve the issue that you were investigating. So they don't have a lot of the complexities that we have. Also, resources are virtually unlimited, like scale your machines, like log more, log less. And then finally, a lot of these companies just charge by the log. So it's in their best interest that you send more logs, not less logs. So it's like, yeah, send us more. We'll happy charge it for them. So just to recap, Why is logging in production taboo on mobile? Turns out logs are expensive. They're expensive on the client. It's expensive to collect them. It's expensive to store them. It's expensive to send them. You're congesting the network. Like, resource-wise, it's very expensive. And then on the server, logs are expensive money-wise. It's expensive to ingest. You need to use compute and bandwidth, and it's expensive to store. It's expensive. More importantly, it's very expensive to not query them. Like, how many times you're like carrying on with your day and some DevOps says like, you realize you're like logging X petabytes of analytics. Do you even look at this? You're like, one day I might. Please don't remove them. They're important. So yeah, that takes us back to like why and what we will want to log in production. What is a log anyway? You keep talking about logs, right? I think logs can be reduced just to events, right? Like something interesting happened, and I want to understand, like I want to have a holistic view of what happened, where it happened, how it happened. Like I want to understand how my app behaves in the wild. I wrote the code, sure, but like I don't know how users are using it and what code paths they're going through. And yeah, logs, like for the purists, is one type of telemetry. Like traditional observability teaches you that there are logs, there are metrics, and there are traces. Well, welcome to mobile. There's also screen captures. Like the most important visibility that we want to have is what was the user seeing? What was the user doing? Like how many times you get a bug report and it says like, this thing is not working. That's a bug report. And you're like, you don't know why. Unless you have a crash, you don't know what's going on. And crash turns out to be like, I don't know, 0.1% of your session, 0.001% if you're doing a great job. So for all the other cases, all you have to go by is like, ask the customer to take a screenshot or maybe like enable extra logs and send a file with the logs. Like, yeah. Turns out if you squint hard enough and logs, metrics, traces, like everything can be a log. They're signals, they're events. Like something interesting happened. We want to know when it happened and what happened. So you see screen captures, yes. Like we believe in mobile, this has been like neglected, right? Like, we don't want to worry about this. Observability is just about logs, traces. So why screen captures? It goes without saying, right? Like it's a holistic view of the user journey. Like it's arguably the most important part of a bug report. But at the same time, it happens to be the final boss of expensive telemetry. And again, if you look hard enough, this can be also modeled as a login problem. In our particular case, where we want to understand what the user did, what the user journey was, it needs to be captured very often. So it has to be efficient. It needs to be allocated in memory, just like logs do. They need to be persisted to disk, just like logs do. And then eventually be visualized somewhere, right? Like you probably don't want to tap into someone's devices as they're experiencing the problem. You want to see it remotely. So, okay, sure, this is unique to mobile. This is not a server problem. Like they don't want to see the screen of a server, what's it doing. But we still need to solve for this. And we first need to solve the login problem, right? Like why is logging in production taboo? It's very expensive. So this is where I would need to have another talk. So let's just assume the magical intelligent log system exists, runs on a device. It can be safely run on mobile in production. It has some kind of very efficient ring buffer storage. It uses all the buzzwords that you can imagine, like flat buffers, and those like good Rust. Let's write it in Rust. It's very efficient. Let's take advantage of low-level things like memory mapping to write to disk in a very efficient manner using the OS. Sure, we have that. Let's keep it to use a fixed memory and this footprint, right? Like nobody wants a log system that takes more memory than the app itself. Like it can be configured to some fixed amount. It needs to support offline support. Like server doesn't have that problem. Like if logs make it to a destination, they make it. So you need some version of smart retries, all of those things. They can be implemented. A lot of companies do this in-house. They have to think about it. They have to worry about these problems. But here's the kicker. Assume you can remotely enable, disable, configure the logs on the fly, right? Like every time it's like, oh, I'm investigating something, let me add one log. I add it, solve the issue, close my laptop, go home. I'm not gonna remove that log ever. It's gonna stay there forever. So let's assume this is part of a magical intelligent log system that we have. It can be disabled, it can be change the verbosity that you're logging on the fly remotely. And then logs don't leave the device unless needed. They just stay in memory, and then like if something interesting that you might investigate happen, then you flush them. And you have an exemplar session. You don't need every single time it happens. You need some exemplar sessions, you investigate, you solve it. Great. So, all right. Well, it turns out, yes, this is what we built at Bitdrift. This is our SDK, does all those things. We're very happy about it. Still doesn't solve the issue about how do we turn a screen capture into a log. We say we have a system, it's great at logs. Can it be great at capturing screens? But you probably are thinking, this is a solved problem, right? Like, aren't screen captures just screenshots? Like, take a screenshot, move on with your life. We have all probably done it. And granted, for a lot of use cases, this might work. This might be enough. Like, there are like bug reporting tools where shake the screen and it will take a screenshot and you will send it over the wire. Yes. In our case, we want to like be a part of every log, be a part of every change the user is doing. So there are a couple of problems with taking actual pixel screenshots for us. Well, half of us wouldn't have a job if Android wasn't messy by nature. So depends on the API that you're using, depends on like the device. You have to deal with Canvas versus there's this very nice new-ish API called Pixel Copy. Behaves differently between API 24 and 26. Then you have this nightmare that is a font window definition on Android. And yeah, if you deal with this, you know it's messy. It can be done like Flipper, like the library from Facebook. They took screenshots, they thought about all these cases, they do it great. But you cannot escape that it's going to be a high CPU spike, right? You need to allocate a lot of CPU. Very exciting. Starting in API 34, Pixel Copy can actually take a pixel representation in a background thread. That's very cool. We tested it. Very exciting. Maybe in 3 years we can use it. High memory spike, you need to allocate every pixel, like at least once. You have to have it in memory. They take a lot of megabytes. Then you probably do compression if you're a good citizen, so more CPU to do that. What are you going to choose, JPEG, PNG? And then you have to store it. So yes, dozens of kilobytes. A log is not that. A log is like, if 1 kilobyte as much, but screenshots take a lot of space. And then by default, you're invading someone's privacy, right? Like then you have to create another system to remove a lot of the pixels that you just capture and obfuscate PII, personal identifiable information. So yeah, this is what your phone looks like. And they still need to run an app, right? You still have a business to run, and then you're taking so much resources just taking a screenshot. So we still did it. We implemented a solution that works. So I don't know, this very simple app using Pixel 7a, API level 33. There's around 50 view elements in this example. The screen capture takes around 50 milliseconds. Not horrible. It takes 10 megabytes of memory to capture every pixel. So you see the spike go up. And it's still 50 milliseconds in the UI thread. You just drop like 3 frames there. You don't want that. You don't want stutter. And then compression can be done in a background thread. It's not terrible. 50 milliseconds, let's say. And the end size, yeah, like 100 kilobytes, sorry, for this very simple screen. So you can only imagine that more complicated screen, more everything. High CPU, high memory, relatively high disk. So yeah, I mean, let's see how well we did with this solution, right? Like according to the title of my talk. Does not impact app responsiveness? Yeah, it probably does. You'll notice the stutter. Requires minimum disk and network usage? No, you still have to upload hundreds of kilobytes per second, per minute. Respects user privacy? Not yet. You'll have to do extra work to do that. Should work for traditional and composed views? Yes. Done. We don't need to worry about what you're using. We're just capturing the pixels on the screen. So 1 out of 4. Drake disapproves. He's pushing this aside. Let's try again. Let's try to turn this screen capture into a log. So spoiler alert, you've seen what it's going to look like. Let's say instead of capturing the screen, we capture a wireframe representation of the screen. And so, yes, we will capture and render in our backend only wireframes. So no actual text or images. We just skip that. We use some lightweight made-up binary format. Like the information that you need to represent that screen is very minimal. you can get away with 5 bytes, one for the type, one for the coordinate x, y, width, and height. So your implementation only need to have access to 3 pieces of data: the view hierarchy, to know the order of your elements in the screen, the layout information, to know the size and position, and the type information, so you can map it to something that looks like a button. So let's implement it on traditional views. Yeah, like we said, all we need is an access to the view hierarchy tree during runtime in the UI thread. Well, yes, it's done. Like if you can access the root, again, you still probably have to deal with the phone window and figure out what the root is. Not an easy problem, but once you have some semblance of a root, you traverse the tree. You do it, in this case, depth first traversal of the tree using getChild of all the children of the view group. Then you get the layer information from the getBounce method, and then you stride the type from the class. And that gives you enough information to represent 90% of what you care about in the screen. So let's try again. We had this previous screenshot example, and now with this case, yeah, like capturing takes like 12 milliseconds, which is what will take you. I mean, this is one data point, but it's whatever it takes you to traverse the tree, like in the UI threads. And then here's the kickers, 350 bytes. Why? Because it's just like 5 to 10 bytes per UI element. So yes, we achieved low CPU, low memory, low disk. There's no compression needed. You already have a binary format. So let's see how well we did. Yeah, should not impact your, we're under 16 milliseconds, should not impact your app responsiveness. Requires minimal disk, minimal network usage, and by definition, it respects the user privacy. We're not capturing what they're seeing on the screen. We're not rendering. We don't even know what they saw on the screen. I think Drake will approve. But let's look at a more complex app, and let's try to like take one screen capture every 250 milliseconds and see how that looks. How do I play this? Okay. So what we want we're very close to achieving real time here. So now you can even think of a scenario where like you actually can tap into a user that is having a problem and seeing what they see without having to like ask them to take a screenshot, ask them to do things. And of course, the big assumption here is that you're a developer of this app. You're familiar with how your app looks. So by giving you wireframes, we believe will give you pretty much a good hint of what the user was doing, what screen they were. That might not be enough, and of course, like there are many things that you can add to enrich this information, but by default, it will give you a wireframe, a very good idea, and our test with our customer has worked pretty well. And most importantly, it should not degrade the app responsiveness. Also, 250 milliseconds for this example is pretty high. You probably don't need that level of fidelity. You can configure this to whatever rate it wants, or you can observe changes and only trigger the capture when meaningful changes happen. There are many techniques to do that. It's up to you how do you want to do it. So we achieved those 3 things, but turns out that by just capturing like the elements in the right order, we have the layers. So we can actually know how the UI is rendering this in which order, because we're traversing it the same way that is presented. So we're able to give you a layout edit or 3D view representation of how your views look. Same payload, same algorithm. It's just like in the front end, we are choosing to render it in 3D in the order that is being transposed. So that also allows you to find these hard-to-find bugs that you can find on the layout editor for the most part, but you can do it remotely for any session that the user has experienced. All right, so yes, like I said, this login system exists today. It's called Bitdrift. It's been deployed to tens of millions of devices, handles a bunch of thousands simultaneous connections. Because that's one important part of this aspect is that in order for it to be dynamic and reconfigurable, it has to maintain a connection to some control plane. And the control plane is the one to tell the device, okay, from all these logs that you're sniffing, do something with them, read them, find something interesting, trigger the flush. So that's the most important part of this architecture, is that you maintain a connection with someone that tells you what to do with these logs, what to look for in these logs. But at the end of the day, the screen themselves without the rest of the context are not super useful, right? Like this is just one tiny piece of an entire holistic view that you want to have. Some products call it breadcrumbs because they kind of encourage you to just leave a couple of them sprinkled here and there. But we encourage you to like log as much as you can, and they will give you like a richer picture. I don't know if I can classic live demo time. Let's see. So yeah, this is how it looks, and what's basically is like giving you the side panel with like all the information, and then we have all the rest of the logs, which is network requests or whatever you want it to be, right? This is the Wikipedia app. And yeah, you can get details on all the logs. And then there are other things, like anything can be a log, right? Like if you take snapshots of how the memory looks like, then you can plot the memory. And then you can see it side by side with the screen that they were seeing. Let's see, we go to this view. This is like a full screen view. And then you can see like, oops, this is not scrolling anymore here. What were happening, what we're doing, what screen they were, how was the memory in consumption, battery, all of these things. Like the moment that you turn everything into a log and then you figure out smart ways to render it on the back end, then it can become a very rich context for whatever you're investigating. So yeah, one half of the equation is this. Let me go back to full screen. And like we said, this other component, not related to this talk, but like there is an engine system that allows you to create rules for when you want to capture these logs. So in this case, it's you're investigating a particular path that the user took. They opened the app, they went to some screen, they rotated the device. At that point, I want you to flush the logs. So I know that a lot of companies, us included, we used to work at Leaf and we built this for them, and then we spun off. We used to abuse Boxnet. We used to like capture handle exceptions when interesting things happen that we were investigating, so we can get the breadcrumbs, so we can get like all that stuff. So basically, so like, okay, let's stop doing that. We will always hit the limit quotas, and we'll have to talk to support to unblock us, and it was like a whole song and dance. They were happy. They were like, "You want us to increase? Pay more." So it's not the right tool. Also, like when you capture a crash, these libraries assume that your system is already like dying, so they can do whatever they want. It's not efficient. Right? Like let's capture, let's write to this, let's do whatever we want. So we turned out that's not a great solution. It wasn't a great solution for us. Okay, back to the title of this talk. So it's like we said it should work for traditional views, and then we said it should work for composed views. How hard could that be, right? All we need is access to the view hierarchy, like we said during runtime. Well, it turns out it's quite hard. Like the compose tree, if you want to call it that, is very complex and it has way more things that are not necessarily views. It has like, and don't get me started with subcomposition. So yes, it's complicated. So there's no like open APIs like you could file publicly and that will give you what you want. Well, that's what we thought, but we were like, I mean, if they can do it, we can do it, right? Like the layout editor, somehow they figured out how to render all the elements. That's a wireframe in the gray lines there, and that's what we want. So let's see what they do. Let's extract it. It's all available, open source. Well, I'm here to tell you that we did it so you don't have to, because it's definitely not a great solution. It's not meant to be called in production. Drake would not approve. So some of the challenges, I mean, goes without saying that everywhere in the code says this interface is not intended to use directly. This API is for tooling only. But, you know, I have my founder mode on, and I was like, yeah, you won't tell me what to do. So we look at the APIs they use, some reflections, some bypassing internals, like not proud of this. But turns out they're slow. And if you use the Android Studio, you can attest that for yourself. Like it takes a while to render all this information, right? Like it blocks the entire thing. So there were some optimizations that the team has done, which is great. It still will take hundreds of milliseconds, which is pretty bad. It's worse than the screenshots. And then the key aspect of it, like the part that we were reading, which is called the source information, we actually used this solution probably like a year and a half ago, and it's been a cat and mouse like game that we played with Google, because they used to leave this information there even in production, but it was wasteful, so they started removing it. So they do 2 passes. They do one pass with a compose runtime compiler, which removes it. There's some flags that you can add to enable it. And there's also program rules on one of the dependencies that will remove them as well. So after a lot of time, we talked to the Google team, and they were like, yeah, you should not be using this. Makes sense. Thank you. We knew that. But definitely a lot of challenges. Do not recommend unless it's a debugging tool. Go for it. If you, it will give you a lot more information, actually, than what we need. It will give you the line of code, like where your compose it's being defined. It will give you a lot of cool information. So we did not do that, and what we do recommend is to use the semantic APIs. So there are these APIs that are created for accessibility tools. So if you ever enable TalkBack, it will be able to like read what's on the screen and be very descriptive of what it is. This is a button, you know? And it's also used for UI test automation. If you ever use the UI test automation tools that you can say like, on this node, tap this button, and it's very semantically rich. Turns out this had everything that we need. So using in production, it's used in production, right? Like accessibility, TalkBack, it's a production system that users, real users, are supposed to use on your app. And if you're a good citizen and you care about your visually impaired users, you should probably be providing content descriptions and like useful tags like that. And we can use that to even enrich further, like our wireframes. So yes, you're able to do a tree traversal of all the semantic nodes by using this interface. The Android Compose view exposes something called the semantics owner, has a root, has children, boom, done. And then you're able to extract the layer information using this property for each node called unclipped global bounds. And to infer the type, you can use the role. There's some other kind of techniques that you might need to do in order to enrich it. Sometimes the role is not enough, but I mean, by looking at the source code of TalkBack and accessibility tools, you can get a good idea. It's not very well exposed. There's not a lot of documentation for them, but they're well maintained because it's in our best interest that we build semantically smart applications. So yes, this is what the original talk was supposed to talk about, but turns out that we already wrote a blog post. It's quite long. It goes into the gory details of how you do this, why you do this, and what not to do. Like I said, probably 2 years ago, we implemented it using the other interfaces, and semantic APIs were not quite there either. So it's been a good journey. We basically rewrite our entire implementation, and now we're very happy with the results. Using this is one of the examples of the Compose app examples. It's called GenNews. And then we're able to render it looking like that. Definitely, yeah, very light, 430 bytes to get this screen representation. It's very small. View element counts, so 60. You still do it in the UI thread. Like there's no walking around that. But at the end of the day, it's a tree traversal thing. So we are able to mostly P90 on most of our customers be able to stay below the 16 millisecond threshold, maybe 20. Like, yes, we might be dropping one frame there. So we'll still be considered to be low CPU, low memory, disk and footprint to be an acceptable solution for us. Your mileage might vary. So our takeaway is you can log everything in production and get away with it. So why not? Like, just don't have to send it all the time. You just have to kill your device. But ideally, you should start rethinking that shouldn't be taboo for mobile developers. Shouldn't be like, no, only backend engineers can do that. We have different constraints. We can come up with different solutions. Let's see. Okay, yeah, if you come to our booth, you will see like a very important example. We made this app with Compose. And we wanted to see how real-time we were able to get it. And I think I have another video. Yeah, so we're able to like render it pretty real-time. So another part of our solution is we have a device ID for every connection that the SDK creates. So we have a tool. It's actually a console line command. And if you give us the device ID with some commands, we're able to tap into the device if it's connected and show you the logs and send you the screens. And all of this happens without us storing the logs anywhere. It's literally, we're just like tunneling through. We're not storing those logs. You can see, you can investigate, sniff it. I mean, we get it that it's kind of an edge case, but it was just too cool to not do. We just like, we can do it, let's do it. So kind of this is an example where like the app is being run, the logs are on the back, on the bottom, you have the screen representations, and then again, everything is a log. You can turn logs into charts. At the end of the day, you're counting things. You're saying like, oh, this is happening 17 times, a jump. Let me just create a chart for jumps. One of the properties of my logs is the score. I'm going to create a chart with a score. I'm going to extract that property from the log and create a chart. Like, no need to have like a different metrics API and a different tracing API and a different logs API. It's all logs. So yeah, with that, I think we like to say, just say no to the logging industrial complex. We can log, we should log, we deserve logs. So yeah, thank you. If you have any questions, it's the right time. You can stop by our booth, see the live demos, get a tiny chainsaw, 3D printed. Our code is available in GitHub. Please fix all our bugs. And yeah, thanks.